Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 18, 2025, about 6 days ago. It shows that a new system for synchronous reinforcement learning rollouts can boost end-to-end rollout throughput by between 74 and 97%, while cutting long-tail latency by about 75 to 93%, all without changing the underlying learning algorithm. The paper is titled Seer, Online Context Learning for Fast Synchronous LLM Reinforcement Learning. And as we will see later, the implications for training large reasoning models at scale are pretty dramatic. Alright, Table 1 quantifies just how dominant the rollout phase is in these reinforcement learning workloads. The table shows that rollout takes about 84% of time for Moonlight, 63% for QWin2 Vision Language 72B, and 87% for Kimi K2. Training only uses between 10 and 31%, while weight updates take just a few percent. This imbalance motivates why speeding up rollout can dramatically accelerate overall reinforcement learning training. So the previous table quantified rollout cost, and Figure 1 now illustrates why naive scheduling wastes so much capacity. The top panels show group-level rollout, where some instances get stuck with long request groups, others sit idle, and each instance repeatedly hits memory limits, causing preemption and recomputation. The bottom panel shows Seer's rollout, which divides groups into chunks, balances work across instances, and smooths key value usage so that GPUs stay busy and total generation time shrinks. Alright, Figure 2 shows how extreme the response lengths get during rollout across 3 real reinforcement learning tasks. The curves reveal that outputs range from a few hundred tokens up to nearly 100,000, which is an enormous spread. Moonlight and Kimi K2 in particular have means above 20,000 and almost 40,000 tokens. So many trajectories are extremely long. This combination of high averages and heavy tails creates serious pressure on memory and makes long-tail latency almost inevitable without smarter scheduling. Well, Figure 5 lays out how the whole Seer rollout system fits together. The request buffer at the top center breaks groups into chunks and feeds them to the inference engine pool, so each instance works on balanced pieces of work. The context manager on the right tracks length and pattern information, then drives both divided rollout scheduling and group speculative drafting. At the bottom, a shared key value cache pool lets instances migrate chunks without costly recomputation, which keeps accelerators busy while latency stays low. So Figure 7 moves from architecture to concrete rollout performance across the 3 reinforcement learning tasks. The grouped bars and lines show that Seer consistently finishes iterations faster while delivering much higher rollout throughput than VRL. The green curves stay well above the orange ones, and the green striped bars are always shorter, so each iteration both processes more tokens per second and completes sooner. The dashed lines highlight that these gains are stable across 10 iterations, not just one lucky run. Okay, Figure 8 digs into why those throughput gains matter so much by breaking out total rollout time and tail time for the 3 reinforcement learning tasks. The orange bars show that in VRL, the last 10% of requests can eat up to roughly half of total time. The blue bars show Seer cutting that tail time by about 85% on Moonlight, 93% on QWin2 Vision Language 72B, and 75% on Kimi K2. This drastic shrinkage of the slowest requests directly explains the big jumps in overall rollout throughput. Well, Table 6 spells out how much each Seer component boosts rollout throughput across the 3 reinforcement learning tasks. Divided rollout alone raises throughput by roughly 27 to 35% over the baseline, depending on the model. Adding context-aware scheduling nudges that to around 33 to 47%. Once adaptive group speculative decoding joins in, total speedups reach about 77% for Moonlight and Kimi K2, and roughly 87% for QWin2 Vision Language 72B, which matches the headline gains we heard before. So the big picture is that online context learning turns messy, long rollouts into well-scheduled, shared work, which boosts throughput by around 80% and slashes tail latency without touching the reinforcement learning algorithm itself. That makes large reasoning model training far more practical. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.